Hello guys, welcome to Fire Racer Workshop, and in today's video we're going to be performing another experiment on Tinkercad, not on ORCAD, okay? Because I'm just like doing a series on ORCAD, so you people might have thought that okay, so this experiment will also be on ORCAD, but no, this is going to be on Tinkercad. And the reason for performing this experiment on Tinkercad is that this experiment just looks really good when it's performed on Tinkercad, and you just get up realistic results while performing this experiment. So let's just fire up the Tinkercad. So the aim of the experiment is to study the basic logic gates. Okay, so we are going to study the 6 logic gates in this video. So let me show you. Let's just create a new circuit. So now we are in Tinkercad. Let's just switch the components to all. First of all, let's just import the breadboard. So this is the breadboard. And the beauty of Tinkercad is that we will simulate the 6 of the logic gate at once. So I'm going to show you how to do that. Now, next of all, we need a switch. And we are just going to import this 4x DPI SPST switch. Okay, so this is what we want. Actually, this is also called the DPI switch, but I don't know why it's just labeled as, okay, no, actually it's a DPI switch. So I'm sorry, it's labeled as a DPI switch as well. So we're just going to place it over here. So over here you can see these dots. So these are the contacts of the DPI switch that are attached to these points on the breadboard. So what we need is we only need 2 of these switches. So we just don't need 4. So we only need 2 of these switches. So next we're gonna import our power supply. So there's a power supply that we're gonna be using. We're gonna set it to 5 volts, and we're gonna current limit this power supply so that we don't blow up our ICs like this is real world. Okay. So as we just can't perform this experiment on real world right now, so we're just gonna assume, okay, so we are just performing it in real world. So we're gonna set up the real world parameters. So next we need all the logic gate ICs. So these are all the logic gate ICs that are available on Tinkercad. So what we need is a NAND gate. So we're just gonna place it over here. We need a NOR gate. Let's just maintain some distance between the ICs. Then we need an AND gate. Now I've just shown you the datasheet for each and every IC, and you also know the truth table of the IC. Now the truth table for each of these ICs is being shown on your screen right now. So we're just going to verify that if the truth table for these ICs is correct or not by simulating this circuit on this particular platform. So next we need the quad OR gate IC. So these are all quad logic gate ICs. So the last IC that we'll be needing is the 74H686, and I just remember that we need another IC. So the name of that IC is the hex inverter IC. So over here there's a hex inverter IC. Let's just place this IC over here, and you have to just make sure that the placement is correct. So it should not be placed like this, otherwise it is just gonna short the terminals of the ICs. It should be placed like this on the breadboard, so these 2 sides are isolated. So this is 1 2 3 4. So this is a 7 into this is a 14 pin IC. So let's just connect everything up. Now we are going to import the multimeters. So we need 6 multimeters for this particular circuit. We also need a resistor. Now the resistor is gonna pull down these particular points. So we want to rotate the resistor first. So this resistor will act as a pull down resistor when this is not connected to the VCC, so that our input does not bounce around. So however, in Tinkercad the input doesn't bounce around, but in real life you gotta be using a pull down resistor along with it. Otherwise this has some capacitance and this can have some residual charges, so it's better to have a pull down resistor over here, so as to pull down the input when the switch is off. So we're gonna set this value to 1K only, so 1K is a perfect value. Now let's just wire up this resistor to the ground. And this resistor as well, we're gonna wire up to the ground. Change the colors to black. Now you see the advantage of using Tinkercad over the ORCAD software is that you just see that, okay, so how does the circuit actually look like in real life. So I'm just gonna wire up the multimeters real quick. So I'm just gonna fast forward this part of the video. So let's just wire up the positive terminals of the multimeter to the output. So in this case, the pin number 1, I'm sorry, this is not the pin number 1, this is a pin number 3. So this is the output for this particular logic gate IC. Now we are all set. Now there's one more thing that you can do if you want to. You can also add some LEDs to the mix so as to like make your circuit a bit more appealing if you want to, but I'm just gonna go ahead without LEDs. So our power supply has been set correctly. DPS switch is at right position. So let's just simulate this circuit. Okay, so both the inputs at this particular point of time are at 0 volts. So when both the inputs are at 0 volts or both the inputs are at 0 logic level, so for our first IC, that is the AND gate, so we are getting a 5 volts, so that's the 1. And for our second IC, that is the NOR gate, we are getting the output as 1. And for the third IC, that is our NOT gate, we are getting the output as 1. And for our fourth IC, that is the AND gate, we are getting the output as 0. And for our fourth and fifth IC, that is the OR and XOR IC, we are getting the output as 0 and 0 respectively. So when one of the switch is at high position, now over here in this particular case, for the first IC, we are getting the output as 1, second is 0, third is 0, fourth is 0, fifth is 1, and sixth is 1. And when when the other output is at 1 and the first output at 0, so we're just going to reverse this condition. So then also we are getting the similar result. So 1 0. Over here this has changed, so the hex inverter IC has changed. So this was earlier, this was 0s, and now this is 1. So essentially it is just an inverter. So this is how it just functions. So, and for the third IC, for the fourth IC, we're getting a solid 0, fifth is 1, sixth is 1. And when both the inputs are at 1 or both the inputs are at 5 volts, we are getting first as 0, second as 0, third as 0, fourth as 5, or you can call it 1, fifth as 1, and sixth as 0. So we'll just verify this table with, I'm just going to plot this table on an Excel sheet, and we're going to verify it with the actual truth table of all these ICs. So our experiment has been performed successfully. So anyways, thanks for watching my video, guys, and over here on your screen now you can see the comparison between the truth table of the particular ICs and the truth table that we have just obtained. So you can see there's an exact match of the truth table. So thank you all for watching, and don't forget to like, share, subscribe to my channel, and please also watch my video that I've made on this particular circuit that I've just simulated on the ORCAD and PSpice. So please watch that video. Also click on the pop-up I button to watch that video. So that's also a really interesting video. Thank you all for watching. See you in the next video.